Hi dear friends and viewers, welcome back to our channel N. Kumar Basics of Physics. Dear friends, in this video we are going to discuss about the what are n-type semiconductors. In that semiconductors, which are the majority charge carriers? Why electrons only majority charge carriers in n-type semiconductors? And what is the position of Fermi energy level in case of n-type semiconductors? And what is the expression for conductivity of n-type semiconductors? Let's discuss. So dear students, before starting the video, my request is watch the video till end, then only my content will reaches you. Okay, so dear students, first thing is what is meant by a pure semiconductor or intrinsic semiconductor. Pure form of semiconductors is called intrinsic semiconductors, and especially germanium and silicon are taken as the example for pure semiconductors. In those semiconductors, the conductivity is very less. Why? Because in those semiconductors, tetravalent electrons are there. Those can form the 4 covalent bonds. That's why there are no valence electrons. That's why conductivity is very less. I already explained the same thing in the previous video. You must watch it. Now, here, what is meant by doping? The process of adding impurities. The process of adding impurities to the pure semiconductors, that should be what we call doping. So due to the process of doping, there are two types of semiconductors are formed. They must become under the category of extrinsic semiconductors. So what we know, extrinsic semiconductors. Extrinsic semiconductors are two types. Those are the first one is p-type semiconductors and next one is the n-type semiconductors. Clear? So in case of p-type semiconductors, already we discussed in the previous video. In p-type semiconductors, holes are the majority charge carriers and electrons are the majority and electrons are the minority carriers. Clear? And when the p-type semiconductor is formed, when trivalent impurities are added to the pure semiconductors, then p-type semiconductors are formed. Now for n-type semiconductors, we have to add the pentavalent elements or atoms should be added to the pure semiconductor, then n-type semiconductors are formed. When pentavalent impurities are added to the pure semiconductors, then n-type semiconductors are formed. So in n-type semiconductors, what happened? Let's discuss here. Children, if you want to get the clear idea about the p-type semiconductors, I already uploaded one video for the n-type p-type semiconductors. That should be available in our playlist. You have to check it. Clear, children? So in case of n-type semiconductors, we are taking some pentavalent impurities like phosphorus or arsenic or antimony. They should be added to the germanium or silicon. Clear? When phosphorus or arsenic should be added to the germanium or silicon, then n-type semiconductors are formed. Here now I am going to explain here like this. This is a pentavalent element that should be added to the pure semiconductor. In that, so many atoms are there here. So these are having some germanium. We are going to take germanium, again same thing. So you can take germanium or silicon water maybe. So germanium and silicon both are having the 4 valence electrons. For that, what we are adding? Phosphorus or arsenic. They should be have 5 valence electrons. Look here, now what's happened here? This is the one pentavalent element that should be added to the one pure semiconductor. Then what happened? Let's see here. So here 1, 2, 3, 4 and 5. These are the 5 valence electrons of particular impure atom. So here we are adding a phosphorus or arsenic, that should be taken as impure atom or impurity. So here what we know, for germanium there are 4 valence electrons, 4 valence electrons. That's why this central atom what we are taking pentavalent, that should be forms the 4 covalent bonds like this. Third one, and this is the fourth one. So the impurity what we added, that particular atom, that should be forms the here 4 covalent bonds with the surrounding germanium atom. After, look here now, very simple. First covalent bond, second covalent bond, third covalent bond and fourth covalent bond. Then obviously there are 4 valence electrons for germanium. That's why here the possibility per phosphorus how many there? 5 there. For germanium how many there? 4 there. Total how many? 9. So possibility of covalent bonds how many here? 4 covalent bonds. 4 covalent bonds. So that means what? One excess electron is there. Clear. In case of central atom, that should be what it is, impure atom, that should be has 5 valence electrons, and the germanium or silicon what we have, that should be having 4. 5 plus 4, 9 electrons. The possibility of covalent bonds are how many there here? Electrons are 8 and 4 covalent bonds are there. That's why here the central impure atom should forms the 4 covalent bonds with the surrounding of germanium or silicon atoms. Then there is some here, one excess electron it is there. One excess electron it is there. This excess electron is nothing but here majority charge carrier in the n-type semiconductor. For one phosphorus we have one valence electron is there, or one excess electron is there. If you can take another one more. If you can take one more, like that. That means due to the so many impure atoms we have so many additional electrons. Because of these additional electrons only the conductivity takes place in n-type semiconductors. There is no need of any additional temperature is given to the n-type semiconductors for the moving of electrons, because already the electrons are so many there in n-type semiconductors. Got it? So after formation of 4 covalent bonds with the surrounding atoms, there are so many valence electrons are there. That's why here there is no need to give any additional energy to that particular n-type semiconductor, because already there are so many excess electrons. That's why here what you have to say, in n-type semiconductors electrons are the majority and holes are the minority charge carriers. Clear children? You have to remember in this case what it is, the electrons are so many are there, electrons are so many electrons are there. That's why simply here I am going to write here Ne is greater than NH. NH. What is Ne here? Number of electrons. Number of electrons that should be greater than the number of holes. NH means what? Number of holes. So that means simply what, right? The amount of current due to the electrons is greater than the number of S, the current due to the holes. IE, what it is? Current because of electrons, and IH, current because of holes. That's why IE is greater than IH. Clear children? So in this way we can write here the conductivity is also we can write like this, Ne into mu into E. What is sigma here? Sigma is the conductivity and Ne is what? Number of electrons, and E is the electron charge or electron, and what is mu? Mu is the mobility of the electron. So conductivity, and this is the mobility. So that's why what you have to do, children, in case of n-type semiconductors, electrons are the majority charge carriers. That's why Ne is greater than NH and I is greater than IH. and basically here n-type semiconductors are electrically neutral and p-types are also electrically neutral. Now how we can identify the Fermi energy level in according to the energy bands in case of n-type semiconductors? So here valency band, and this is energy gap, and this is what? Conduction band. So after the conduction, all the electrons are in conduction band only, that's why here the Fermi energy level is very close to the conduction band when the absolute temperature is greater than the 0 Kelvin. So temperature is greater than the 0 Kelvin, the Fermi energy level is close to the S conduction band. So children, this is about the n-type semiconductors. Very simple. This is the enough data for 4 marks question what you are getting into the intermediate public examinations. If you can understand this one, like, share, comment the video. Thank you for watching.